Let's take a look at the solutions to question number 3 from the 2018 test. Keep track of your points. If you weren't sure how to do these, make sure you get out a sheet of paper and follow along. Remember, the idea is to study these problems after we go over them, because it's really the type of questions we're interested in knowing how to do. So for question 3 here, the graph of the continuous function g, which is a derivative of the function f, is shown above. The function g is a piecewise linear function for this interval, and g of x is equal to this expression for this given interval. So for question A, if f of 1 is equal to 3, what is the value of f of negative 5? So what we're going to write out here is that f prime of x is going to equal g of x, because g of x is equal to the derivative of f. Or we could also write this, that f of x is the antiderivative of g of x. So those two facts are going to be very helpful. So if f is the antiderivative of g of x, and we need to find an f of x value, we could write it this way. So if I'm looking at 1 and negative 5 here, so I could write the integral from negative 5 to 1 of g of x dx using the fundamental theorem of calculus part 1. That just becomes f of 1 minus f of negative 5, because if f is the antiderivative of g of x, we can write this now. And then I could just rearrange this. If I need to solve for f of negative 5, I could just move this to the other side. It becomes positive. So I could say f of negative 5 is going to become f of 1 minus the integral from negative 1 or negative 5 to 1 of g of x dx. So they tell us f of 1 is equal to 3. And then to calculate this integral, I just go and find the areas between the curve and the x-axis. And any area that's going to be below, because this is helping me evaluate an integral, I'm going to make it negative. So if I first just take a look at this square, find the area here, that's just a 3 by 3, so it's going to be a negative 9. And then I look at this triangle, that's also going to be negative, so that'll be minus 1/2 of 1 times 3. This part right here has no area that we could shade in, so that's just 0. And I just need to go to 1, so then this last part here just becomes a positive 1/2 times 1 times 2. And then we just calculate this. So we'll get 3 plus 9. We'll get plus 3/2. This will give us a 1, and we'll subtract that, so minus 1. So we get 12 minus 1, 11, plus 1/2, so we're going to get 12.5. So that is the value of f of negative 5. So 2 points for this problem, 1 point for setting up and using the integral. So we'll say this, either this step or this step, and then 1 point for the answer. Let's take a look at part B. Here they want us to evaluate the integral from 1 to 6 g of x dx. So here's what's a little bit different. They're not asking us for f of 6. So I'm not just going to do f of 6 minus f of 1. What we are going to do is just the same thing that we did for the integral in the last part, is just calculate the area. So we're good with all line segments until we get to the parabola that's right here. So I could write this as, if we're just going from 1, I can just separate this from 1 to 3, and that's a nice square. So I get a 2 by 2 as we set that up. And then from 3 to 6, I'm going to use this expression. So then we're going to say plus the integral from 3 to 6 of 2 times x minus 4 quantity squared dx. So now we just have to evaluate that integral. So we're going to get 4 plus, now you might be able to figure this out without it, but I am going to just use some very basic u substitution. I'm going to let u equal x minus 4, then du is going to equal dx. So then this becomes the integral. I could put the 2 out in front. 2 times the integral as x goes from 3 to 6 of u squared du. So now I get 2 times u cubed over 3, again as x goes from 3 to 6. And then we'll bring back u, which is x minus 4 cubed over 3 as x goes from 3 to 6. So we're going to get 4 plus 2 times 6 minus 4 is 2 cubed will give us 8/3. Minus 3 minus 4 is negative 1. So that's still going to give us a negative 1/3. So we're going to get 4 plus 16/3 plus 2/3. That's 18/3, so we get 4 plus 6, giving us 10. We get 3 points for this. 1 point for technically splitting this. So this part right here can also be written as the integral from 1 to 3 of g of x dx. So you get 1 point for knowing to write out 2 separate parts. 1 point for taking the correct antiderivative. And then 1 point for the answer. 5 points right there. All right, question C. For the interval that of x between -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. So this is what's going to be very helpful. We know that f prime of x is equal to g of x. And then f double prime of x would equal g prime of x. We need to use that here. So we're going to say f of x is increasing and concave up when f prime of x, which is equal to g of x, is positive, and when f double prime of x, which is equal to g prime of x, is positive. We would say this happens on the intervals, so we need to know, first we're looking where g of x sits completely above the x-axis. And then we also need to know where the second derivative of f of x, so the derivatives or the slopes of the tangent lines are positive, so that happens right here between 0 and 1, and then over here between 4 and 6. So we would say this happens when x is between 0 and 1 and 4 and 6. And we don't include the 0 because right at x equals 0, our graph is no longer positive. So we don't include any, the 0, the 1, the 4, or the 6. All right, so for this one, we get 1 point for the intervals, 1 point for the reason. Let's take a look at part D. Find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. So we would say a point of inflection. Now remember, even though I'm abbreviating now, don't abbreviate anything when it comes time for the actual test. So a point of inflection occurs when f double prime of x, which is equal to g prime of x, changes either from positive to negative or negative to positive. So we'll just say changes sign. So what we first have right here, all the slopes right here are 0, and then it turns to positive. So that's not changing sign. Then it turns back to 0 again. So that's not going to happen. Notice how we have a corner here. So it doesn't change from positive to negative. It changes from just being 0 to positive back to 0. All right, then we're positive again. And we're 0 again, so no points of inflection yet. Then it changes to negative. So we still don't have a point of inflection here. And then it changes to positive. So the only place right here is at x equals 4. So 2 points for this, 1 for the answer, 1 for giving the reason.